I think this is a really fun section because we're going to be talking more about different types of angles um, and there's a little bit of algebra in it. So I think that it's fun, at least for me. I hope that you guys find it as fun also. But this section deals mainly with angles, and of course, there's going to be more vocabulary here. I want us to see, first of all, that we have a set of two intersecting lines here, line L and line M, that are intersecting right here in this very point. Well, when that happens, these angles here, like say angle 1 and angle 3, that are exactly opposite each other, those are called vertical angles. And vertical angles always have the exact same measure. Now, also, angle 2 and angle 4 would be vertical angles, and they would have the same measure as well. Now, the definition of a vertical angle says that they are created by intersecting lines, which we can see from here. They are a pair of angles whose sides are two pairs of opposite rays. So, opposite being from the original angle. And then we have a theorem here that says vertical angles are congruent. Now, there's a little bit more vocabulary here that we're talking about supplementary angles. And supplementary angles, that means that two angles add up to be 180 degrees. That's the definition of a supplementary angle. So here we have a couple or three examples. This example shows you a 140-degree angle and a 40-degree angle. Well, if you add those together, they would add up to be 180 degrees. And I don't know if you can picture this or not, but if you were to take this 40-degree angle and move it over here and kind of flip it over, it would lie right along here. And that together would create a nice straight line. And if you'll remember, a straight line has a degree measure of 180 degrees always. Here's another picture of an example of supplementary angles. And again, you can see that they're forming that 180-degree straight line. And then all supplementary angles have to add up to be 180 degrees. So whatever one angle is, the other angle has to be 180 minus that. Now we also have what are called complementary angles, and complementary angles add up to be 90 degrees. So here we have a couple of examples here, like this 60 and 30-degree angle. Those would be called complementary angles because they are complementary to each other. If I were to, again, take this angle and move it over to here, and drop it right in there, that would make that a 30-degree angle. Do you see how that forms that nice 90-degree angle? Here's a picture of one, a 70-degree angle and a 20-degree angle coming together to form that nice right 90-degree angle. Now we also have some other vocabulary that we talk about, especially when we talk about two lines cut by a transversal. And here we have two lines, and these are not parallel. A lot of times we talk about them being parallel, and we will on the next page. But when it says cut by a transversal, that just means that a line goes through both of those and forming angles on either side of those two straight lines. Well, we have some vocabulary that goes along with this. First, the vocabulary is talking about interior angles, and those are between two lines cut by a transversal. So let me show you what that means. These are all interior angles. They're on the inside of the two lines. Exterior angles are not between the two lines. So our exterior angles would be like 1 and 2, 7 and 8. They're on the outside of the two lines. Alternate interior angles would be exactly what it says. They're alternating interior angles. So they're interior angles but alternating on either side of that transversal. And then also we would have angle 4 and angle 5 would be considered alternate interior angles. We have alternate exterior angles, which would be things like 1 and 8. They alternate the side of the transversal, and they are exterior angles, so they're alternate exterior angles. Finally, we have corresponding angles. Corresponding angles are the same relative position when the two lines are cut by the transversal. Now, what that means is angles like 2 and 6. They are in the same relative position. They are up above and on the right side of the transversal for each of those lines. So we would call those corresponding angles. Um, Angle 1 and angle 5 would also be considered corresponding angles because they are again on the same left side of the transversal, both above the two lines. So we need to really focus on learning our vocabulary because that's what we're going to be talking about in this section. Now here we have two parallel lines that are cut by a transversal. And whenever you have this situation, then some of those features that we just talked about, that vocabulary, those turn out to be the exact same thing. So let's go over this. If the lines are parallel, then the corresponding angles are congruent. Corresponding angles are congruent. Now, do you remember what congruent means from our last section? Congruent means that they have the same measure. So here our angle 1 and our angle 5 both have the exact same measure because they're corresponding angles. Also, alternate exterior angles. Alternate exterior angles are congruent. So remember, alternate exterior would mean like angle 2 and angle 7 on the outside of the two parallel lines and also on opposite sides or alternating sides of the transversal. Finally, alternating interior angles are congruent. So alternate interior angles are congruent. So alternate interior angles, if you'll remember, those are on alternating sides of the transversal on the inside of the parallel lines, like angle 3 and angle 6.